So today we're going to kind of delve deeper into the atom and talk about what it's made up of, the protons, neutrons, electrons, and we're going to talk about ions as well. So we kind of learned about the history of the atom, so now we want to look and investigate a little closer. So we've decided that we have a current atomic model, and it's the Bohr model with a couple of additions from different scientists, which we've got our protons and neutrons here in the nucleus with orbiting surrounding electrons. Okay, so let's talk about each of these and how we can talk about them and how we can look at the periodic table, because the periodic table is going to be an essential part of the rest of our time here in chemistry, and we need to be able to glean this information, the amount of protons, the amount of neutrons, all that kind of stuff from the periodic table, and so we're going to talk about how we can do that. So, back to the basics of what makes up an atom. An atom is made up of a nucleus, which contains our protons and neutrons, and then surrounded by orbiting electrons. So the nucleus has our protons and our neutrons, which make up the majority of the mass of the atom, and then we're surrounded by orbiting electrons. Now our protons, which we symbolize with an H plus or a P plus, have a positive 1 charge. They're a positive charge in the nucleus, and they've got a really small mass, 1 times 10 to the negative 24. Our neutrons are neutrally charged and have the symbol 1, 0, and N, and they're neutrally charged, and again, they have a similar mass to the proton, but slightly bigger. And then we have our electrons, which we symbolize with an E minus. This is our negative charge, and it is a fraction of the mass of our protons and our neutrons. So don't forget, one of the things that we learned when we studied the history of the atom is that the protons and neutrons in the nucleus make up the majority of the mass of the atom. The electrons, that negative charged cloud, makes up just a fraction of the actual mass of the atom itself. Now, since all elements are going to be made up of protons, neutrons, and electrons, how are you going to be able to tell them apart, since they all are made up of the same thing? And the way that we do that is because different elements have different numbers of protons, neutrons, and electrons. Now let's talk about atomic mass, which is sometimes referred to as atomic weight. The atomic mass of an element is a weighted average of the mass of the atoms in a naturally occurring sample of the element. Now, something that we're going to delve a little more into tomorrow, but we'll talk about a little today, is something called the isotope. And different atoms of the same element can actually have different numbers of neutrons. And since the neutron is part of what makes up the mass of an atom, if different atoms have different number of neutrons, those different atoms are going to have a different mass. And so the atomic mass that we give and list on the periodic table is actually a weighted average of all of those atoms based on their prevalence and stuff like that. And so we'll talk more about isotopes tomorrow. But for now, what you need to know is the atomic mass takes into account all those different weights or masses of the atoms and is a weighted average of all of those. The mass of the atom, since it's primarily made up of protons and neutrons, that's why we have to talk about that weighted average. And we give that, since it's a weighted average, it's not actually a whole number because you're dividing and doing all the averaging things that you need to do, and so sometimes we don't get whole numbers. And in fact, fluorine has an atomic mass of 18.9984032. So that number is our atomic mass. So when you look on the periodic table and you see numbers with decimals, that's always our weighted average atomic mass. There are a couple elements on the periodic table that don't have, they don't have decimals in their atomic mass, but those masses are also listed usually in parentheses or brackets. And that is because these elements are unstable. And so some of their isotopes are unstable, and so we can't have an average, or we can't have an atomic mass of them because they don't last long enough for us to actually weigh them. So our weighted average then doesn't have a decimal because we're not as specific about that. Now let's talk about atomic numbers. So that was atomic mass. This is atomic number. The atomic number is the number of protons, and it's what distinguishes elements from each other. Each element has a specific number of protons, and that is the atomic number, or Z. So if we look here, we've got fluorine and lead. Now, fluorine's atomic number is 9, lead's is 82. That means fluorine has 9 protons, lead has 82 protons. Oxygen has 8 protons, and so the atomic number of oxygen is 8. The atomic number is specific for each element. If you change the number of protons, you change the element. So that's something to keep in mind. Changing the number of protons changes the element, and that's why it's given as our atomic number, and it's so important in the periodic table. Well, what about something called mass number? So we've had atomic mass, atomic number, now we've got mass number. Mass number is the number of protons and the number of neutrons, and it's given the symbol of A. Different atoms, like we said, have different, of the same element, can have different number of neutrons. So we've talked about that. That's the whole idea of isotopes. So since different elements of the same, different atoms of the same element can have the same different number of neutrons, mass number cannot really be given on the periodic table. That's why instead we give that weighted atomic mass. The mass number can't be found on the periodic table, but we can list it. So let's look a little bit. These are two examples of how you could write lead. Lead on the periodic table is normally found with 82 and 207.2 with no mass number. But we could write lead like this, where we've got our A on top and our Z on the bottom. A is our mass number. It's telling us that it has that many number of protons and neutrons, and 82 of those are protons with my atomic number there. So if we are wanting to know the number of neutrons in an element, we have to give the mass number, and we have to specify what isotope it is. So like uranium-235 versus uranium-238, we have to give the mass number, or we can write it like we did with this lead. So mass number is not something that is given to you on the periodic table. It has to be specified in a problem if I need you to use that. Now, we've talked about mass number, atomic number, and atomic weight, and they all sound the same, and they're all really closely related. So one of the things that helps me to remember which is the word mass number has the word mass in it. And I know that the mass of an element or an atom comes from its protons and its neutrons. So I know then that mass number is talking about protons and neutrons, rather than atomic number, which is just talking about protons. It doesn't have the word mass in it, so it's not including those neutrons. So that's kind of how I help myself to remember this. So we've talked about different atoms have different number of protons, but different periodic tables are going to give those and write those values in different ways. Like krypton here in this example, the 36 is in the top left. In this example, the 74 for tungsten is in the middle on the top. And here, scandium, it's again on the top left. So krypton is going to have 36 protons, tungsten has 74, and scandium has 21. So it doesn't matter kind of where it is. It doesn't always have to be in the top left-hand corner. It's more important that you can find that it's the smaller whole number. That's always the atomic number. Now, how many neutrons is a bit different. Because the number of neutrons can be different in each atom of the same element, you actually need both the atomic number and the mass number in order to determine the number of neutrons. So you need both of these, like we wrote with the lead. You need the mass number and you need the atomic number. If you have the mass number, you can subtract the atomic number from mass number and get the number of neutrons. So for example, gold, given a mass number of 197 and an atomic number of 79, if you subtract 79 from 197, you get 118. That means that gold has 118 neutrons. So you always have to have both the mass number and the atomic number in order to find the number of neutrons. So you subtract the number of protons from the number of protons and neutrons, giving you then the number of neutrons. Now, what about electrons? We've talked a lot about protons and neutrons, but electrons do, even though they don't make up a lot of mass, they're a really important part of an atom because they talk about how it's going to react with things. And so we do need to know how many electrons we're going to have. So if the atom you're describing is a neutrally charged atom, then the number of positively charged protons is going to have to equal the number of negatively charged electrons. They cancel each other out. So for example here, we've got phosphorus, which is 15 protons, and strontium, which has 38 protons. Given that phosphorus has 15 protons, then it also must have 15 electrons. Strontium with 38 protons must also have 38 electrons. If you're talking about a neutrally charged atom, so just a regular atom, the number of protons and the number of electrons are always going to be the same because you have to balance out that charge. Now, neutrons are neutral, so it doesn't matter that they don't always equal the number of protons or the number of electrons. Sometimes they do, but as we got bigger in size, the atoms started having to have more and more neutrons. So you can always find the number of electrons from your number of protons if it's a neutrally charged atom. But you can't always find the number of neutrons. So what about ions? That's the last thing that we're going to talk about today. Now, if an atom does not have the same number of protons and electrons, the atom's charge is no longer going to be neutral. And so, because the positives and negatives are not canceling out. Since electrons are negatively charged, having more of them compared to the protons will give you an atom with a negative charge. Alternatively, if you have fewer electrons than protons, the atom will have a positive charge due to the positive protons not being canceled out. Now, these have very specific names. And so I want to tell you what those names are, and I want to write it out. Okay, so our positively charged, because it has fewer electrons, it's positively charged, it's called a cation. Spelled just like you would think, cation. A negatively charged ion that has too many electrons is going to be called an anion. You can kind of think of this because an usually means like the opposite or lacking. In English, it's kind of like a root there. So anion is negative, cation is positive. And I've got some, if you look in my room, you'll find some kind of cute posters that talk about cations being positive. So you can kind of keep an eye out for that. Okay. Now I need to get rid of that cool little animation that I just did. There we go. Okay. So keep that in mind. You've got protons, too many protons, you're a cation. Well, not too many, but more protons than electrons, you're a cation. More electrons than protons, you're an anion. And it's all to do with if you have more electrons, you're negative. If you have more protons or fewer electrons, you're positive. So let's take a look and try and figure out how many protons and electrons we have. So F minus. Now, fluorine, this means that it's a fluorine negative ion, so it's a fluorine anion. So fluorine from the periodic table we know has 9 protons. But if it's negatively charged, that means it has too many electrons, specifically one more electron, because it's just a 1 minus charge. So if it has 9 protons, then it's going to have 10 electrons. Okay? Now let's look at sodium, Na+. Sodium has 11 protons, according to the periodic table. That plus symbol means that it is positively charged, meaning we lost an electron, or we lost negativity. So if it had a neutral sodium ion, would have 11 electrons, but since we lost one, we should only have 10 electrons. So 11 protons, 10 electrons. Now, magnesium 2+. That means we lost 2 negatives, or 2 electrons. Magnesium is 12 protons, atomic number 12. So if we lost 2 electrons, that would mean that we should have 10 electrons, because a neutral atom would have 12 electrons. So 2+ means we lost 2 of those. And then oxygen. Oxygen on the periodic table has 8 protons, so a neutral oxygen should have 8 electrons. But the 2 minus means that we gained 2 electrons, so we now have 10 electrons. So I told you that the number of protons, neutrons, and electrons is always going to differ for every atom or every element, and that is true. They will never have the same exact number, but you can have the same number of one of them. And if you'll notice, each of these ions all have 10 electrons. Some of them gained 2 to get to 10 electrons, some lost 2 to get to 10 electrons. Some gained 1, some lost 1. But they all have 10 electrons. They are not the same element. They are ions. And so the number of electrons is kind of fluid in that case. You are changing the number of electrons you have. They all have different number of protons. 9 protons, 11, 12, or 8. So they're definitely not the same element. But they do end up having the same number of electrons. So kind of something to think about. All right, so we're going to continue talking about this tomorrow. So come in prepared to teach me all that you know about the atom. Have a good night.